All right, today we're going to crack the code on a single GCSE Physics exam question. We're going to go through it step by step, not just to get the answers, but to really understand what an examiner is looking for to give you every single mark. Ready to dive in? You know that feeling in an exam, right? You're pretty sure you know the answer, but you're just not quite sure how to phrase it to get full credit. Well, today we're going to pull back that curtain and see things exactly how an examiner sees them. So, this is our focus for today. It's question 04 from an AQA GCSE Physics paper, and it's all about lenses. Now, this is a 10-mark question, and it's got 5 different parts, each one designed to test a totally different skill. And you guessed it, we're going to tackle every single one. So here's our game plan. First, we'll deconstruct the question as a whole. Then we'll dive into each part one by one, describing images, drawing those tricky ray diagrams, interpreting data from a graph, and explaining physical phenomena. And finally, we'll wrap it all up to really get inside the examiner's mindset. Look, the goal here isn't just about finding the right answers. It's about understanding why they're the right answers by looking at the official mark scheme. This is all about learning to think like the person who's actually grading your paper. Okay, let's jump right into the first part, 04.1. This one is all about using your precise scientific language. So, the question gives us this ray diagram for a concave lens. We're told the image is upright, but we need to come up with 2 more words to describe it. This is a classic test of your key terminology. So, what are the exact words they're looking for? And there they are. The 2 magic words are virtual and diminished. A virtual image means the light rays only look like they come from that point. They don't actually cross there. And diminished is just the proper scientific way of saying the image is smaller than the object. Now, you might get away with smaller, but using the word diminished, that shows the examiner you really know what you're talking about. All right, let's move on to the next section. We're shifting gears now from theory to a hands-on skill, drawing a ray diagram and doing it accurately. So what we've got here is a grid with a convex lens, an object, and those 2 important focal points, both labeled F. Our job is to finish the diagram to show where the image forms and how big it is. This is worth 3 marks, so you know precision is everything here. The great news is there's a standard, repeatable method for this. First step, you draw a ray from the very top of the object, running parallel to the main axis. When it hits the lens, it bends, or refracts, and passes right through the focal point on the other side. Second, you draw another ray from the top of the object, but this one goes straight through the center of the lens and doesn't bend at all. And finally, the spot where those 2 rays cross, that's where you draw the top of your image. And there it is, the final result. You can see our 2 construction lines and the image that's formed. In this case, it's inverted, so it's upside down, and it's magnified, which just means it's bigger than the original object. So how do you actually bag all 3 marks for that? Well, according to the mark scheme, you get 2 marks for drawing any 2 correct lines from the top of the object that go through the lens. And that final, crucial mark, that's for drawing the image itself in exactly the right spot and facing the right way up, or down in this case. It's a really clear process. Now for part 3, which tests a totally different skill, interpreting data. No math, no drawing, just describing what a graph is telling you. So here's the graph we're working with. Along the bottom, the x-axis, you've got the object's distance from the lens. And up the side, the y-axis, is the image's distance. The question asks us to describe the relationship between them. Seems easy enough, doesn't it? But here's the trap. The mark scheme is very clear. You can't just say inversely proportional. Why not? Because that's a very specific mathematical relationship, and this graph is clearly a curve. To get the mark, you have to describe the shape of that curve. You have to notice how the image distance drops really fast at the beginning when the object is close, but then it starts to flatten out and decrease much more slowly as the object gets further away. That's the kind of detail the examiner is looking for. We're on the home stretch now. Let's tackle the final 2 parts. These test your calculation skills and your ability to apply physics principles to a real-world problem. So, question 04.4 gives us a set of 4 measurements for the image distance: 1.9, 1.7, 2.2, and 1.4 centimeters. Our task is simply to calculate the uncertainty. And again, there's a simple 2-step method for this. To find the uncertainty from a set of readings, first you find the range. That's just the biggest value minus the smallest value. So here it's 2.2 minus 1.4, which gives us 0.8 centimeters. Then you just divide that range by 2. And that gives us our final answer for 2 marks, an uncertainty of plus or minus 0.4 centimeters. See, easy marks, as long as you know the method. Okay, last one, 04.5. This is a classic 3-mark question that pulls together our knowledge of light, filters, and color. We've got a spotlight with a red filter, and it's shining on a blue object. The big question is, why does that blue object look black?
To get all 3 marks here, you have to build a logical argument with 3 specific points. First point, the red filter only lets red light through. It transmits red light. Second point, a blue object looks blue because it reflects blue light, but it absorbs all other colors, and that includes red, so that red light gets soaked up by the object. And third, if no light is reflected from the object into your eye, it's going to look black. Transmit, absorb, reflect. Those are the 3 key ideas for the 3 marks.
So we've done it. We've cracked every part of question 04. But let's take a step back and think, what was this all really about? What skills was that examiner actually trying to test with this one question? You see, this question wasn't really just about lenses and light. It was a test of whether you can use precise scientific words, if you can follow a standard method for drawing a diagram, if you can accurately read the story a graph is telling you, if you can perform a basic calculation, and if you can apply the core principles of physics in a logical order. These are the skills that make the difference between a good answer and a great one. And that's the real secret here. This systematic approach, breaking down the question, figuring out what skill is being tested, and thinking about the keywords and steps the mark scheme wants, that doesn't just work for this one question. It's a tool you can use on any question, on any paper. So the real question I'll leave you with is, what other exam questions could you crack with this approach?